Good morning, class.
Morning, sir.
So today we're looking at financial maths. Looking at the examples for exercise 3. The example for exercise 3 is on page 68. And the exercise 3 is on page 70. Okay. So now we're looking at present value annuities. So here we are told that when we're looking at present value annuities, those are cases where you get the money presently. Example of that would be when you buy a house, bond repayments, or you buy a car finance, or you make a loan. Okay? So all of those cases we get the money up front, then we must pay the loan off. Okay? So of course the formula will differ, and the formula there is that we use is going to be present value formula, which is PV is equal to X into 1 minus 1 plus I to the exponent negative n all over I. Okay. That's the present value annuities formula. Again, that is used when we talk about loans, car finance, or bond repayments. Okay. We're looking at example 1. Before we go into example 1, to amortize a loan is to pay the loan back in full. Okay. So let's look at the first example, which is on page 68. We are told, so you see where it takes out a loan to buy a car and will pay back the loan over 3 years. Okay, so it is going to be 3. He plans to pay 2,000 Rand per month starting in 1 month's time, so there's no variation on in there. Calculate how much Caesar will borrow. Now, if the interest rate changed is 14%. Interest rate charged, sorry, is 14% compounded monthly. So that we have enough information to use the formula. So my formula is PV, as because it's car finance, it's X into 1 minus of vehicle finance, 1 plus I to the exponent n, the negative n over I. They want to know how much can Caesar borrow, so we're calculating PV. So he's paying 2,000 Rand per month, there's 2,000 into 1 minus 1 plus I, which is 14%, 14 over 12, compounded monthly, to the 12 times for 3 years, the negative, all over I, which is 0,14 over 12. Okay, so that's going to give you 2,000 into 1 minus 1 plus 0,14 over 12 to the exponent to negative 12 times 3, and that is all over 0.14 over 12. They give me an answer of 58,517 Rand and 81 cents. Okay. You want to see how much interest he actually paid, then you will work it out by saying, since he's paying 2,000 Rand for 3 years at the monthly frequency, minus the amount of the loan. So over 3 years he's paying an interest of 13,482 Rand and 19 cents. Okay. That's basically how you would calculate the interest rate there, the interest, but that wasn't the question asked. Let's look at the example, the next example. Example 2. Example 2, we are told that Azra buys a flat for 760,000 rand. She pays 120,000 rand as a deposit and secures a loan for the balance. So the balance is the PV value, which is going to be 760,000 rand minus 120,000. Okay, so 760,000 minus 120,000. That gives you. So she needs a loan of 640,000. Okay. If she pays back the loan over, pays back the loan over 20 years, the interest is calculated 15% per annum compounded quarterly. Okay, so that's a compounded quarterly. How much will Azra pay each month? So you see now that's a problem. The frequency of the installment, which is a monthly case, is not in line with the frequency of the compounded frequency. Okay. So in other words, I need to convert that to compounded monthly. So what we do is we use that formula 1 plus IE is equal to 1 plus I to the M over M to the M. But M in this case I'm going to use is compounded quarterly, so it's going to be 4 and 4. And then we say 1 plus IE. So once I got the IE, I sub it into here, which is then 1 plus I to the 12 over 12 to the 12. Then I would be able to calculate I to the 12. Okay. Or, as we know that those two are equal, so which makes that 2 also equal. Okay. Which means, say now, and that's the formula I will be using, I can simply say 1 plus I to the 4 over 4 to the 4 is equal to 1 plus I to the 12 over 12 to the 12. Okay, I just derived that from the previous explanation. So it's compounded quarterly, so it's 1 plus 0,15 over 4 to the exponent 4 is equal to 1 plus I to the 12 over 12 to the 12. Now I want to calculate I12. So what I do is I need to work out the 12th root of this. So it's the 12th root of, open brackets, 1 plus 0,15 over 4 to the exponent 4 minus 1 times 12. Okay. So that simply gives us 12 into the 12th root of 1 plus, okay, that must be in a bracket, it's 1 plus 0,15 over 4 to the exponent 4 minus 1. So give me an answer of 0,18 is equal to 0. Okay, it's going to multiply by 100 to get, okay, it's going to keep it so. So I to the 12 is going to be 0,14816, and the number of course carries on. Okay. Now we can use the formula number 2. Now we can use the formula if V is equal to, and also yeah, we didn't finish off the information. Each month into if she pays a monthly starting in 1 month's time. So as we see, there's no variation on your end value there. So it's not future value but present value is x into 1 minus 1 plus I to the minus n over I. Okay. So let's see here. So your present value is, she needs 640,000 Rand from the bank. We're calculating a X value, 1 minus 1 plus interest rate. The interest rate is now 0,14816. And that is over 12, since it's compounded monthly. The negative 12 times. You see that is for how many years? 20 years. And this is all over I, which is 0,14816 over 12. Okay. So if you get X on its own, again I'm going to cross multiply. So that's going to give you 640,123 times 0,14816 over 12. And that's equal to X into that whole bracket. So I divide both sides by that bracket, which is 1 minus 1 plus 0,14816 over 12 to the exponent, negative 12 times 20 equals X. Okay. So let's put that in the calculator. 640 into 3 times the interest over 12. That's 1 minus 1 plus that answer over 12 to the exponent, negative 12 times 20, with an answer of 8,340 Rand. And 72 cents. The textbook gets an answer of 8,342 Rand and 46 cents. The reason again there is because they haven't used the answer button. They use the rounded off answer 14,81 or 82. Yes? 57. But you entered in 0,14816. I use the answer button. Okay, so my decimals is, you won't get marked down. No? Okay. So your X is equal to 8,340 Rand and 72 cents. Okay. That is what she needs to pay on a monthly basis. Okay. Let's look at number 3. Here we are told that James takes out a loan. A loan again, we're going to use. We need to use the present value formula. Okay. Provided she's making quarterly or whatever payments. So he takes out a loan of 62,500 at an interest rate of 12% per annum, compounded quarterly. So you must make quarterly investments so as not to change the interest here. However, if it's a monthly investment, of course the interest rate needs to be changed. If James makes quarterly payments, so which means to say the payments are in line with the interest. If James makes quarterly payments, that starts immediately. So what do you notice here? That starts immediately, then there's a variation on your end value. Okay. Calculate the value of each payment to amortize. Remember what did we say is to amortize the loan? To pay the loan in full. After a full 10 years have passed. That is after 41 payments from now. Okay, so there's a difference here. Eh? So what happens is if somebody takes out a loan, okay, and he starts paying 1 month later, that means to say the person is going to incur an interest on that loan for 1 month. Not so. However, if he's going to start payment immediately, so he takes out the loan, he's not going to incur any interest there, and makes a payment, then that means to say that that loan amount minus that first installment won't bear any interest. Okay. So if we look at that there, again is the future present value formula. So it's x into 1 minus 1 plus I to the exponent negative n over I. So what happens is, whatever the present value is, I must take an x, one payment off from that. Why? Because it's not getting an interest, not incurring an interest on the first payment, because of the first payment. Okay. So let's see. So your PV value, of course, is 62,500. That's number one. Minus x equals x into. Remember the question was to calculate the value of each payment. So it's 1 minus 1 plus. Your interest rate is 0.12 over 4, since it's compounded quarterly. The exponent 4 times, it's for 10 years. And the negative all over I, which is 0.12 over 4. Alright, so what I'm going to do is I'm going to take this x over the equal sign. So that will be plus x. Okay. So what I have now is 62,500 equals, and I'm going to take out x as a common factor here. Take out x as a common factor. Then I'm left with 1 minus 1 plus 0.1412 over 4 to the exponent negative 40 all over 0.12 over 4 plus 1. Okay, so now to get x on its own, I'm going to say 62,500 divided by this bracket. 62,500, and it's it must be divided by. Okay, I don't want to make a mistake there. So let's just put it divided by, and in brackets, I've got the fraction 1 minus 1 in brackets 1 plus 0.12 over 4 to the exponent negative 40 over 0.12 over 4 plus 1. Alright, so that gives you 2,591 rand and 77 cents. 2,591 rand and 77 cents. Okay, that is number one, the first part of the question. The second part says, how much interest did James pay over a period of 10 years? Okay, so now we're calculating the interest that incurred over the period of 10 years. So the amount of money that he paid will definitely be more than the loan amount. Okay. So the interest is simply, he's paying 2,591.77 cents for 10 years. Okay. Per month. But he paid one payment extra. Not so? No, per quarter. And he paid one payment extra minus the loan amount of 62,500. Okay. So let's see. So that's answer into 41 minus 62,500. Gives me 43,763 rand. 43,762 rand and 67 cents. Okay, so that's the amount of interest earned or paid, sorry, in this case, over that period of 10 years. Okay. Annuity application and problem solving. So this is now going to be the next part of the lesson. Alright. Your next lesson.